Welcome to Study Loop.
For the alpha particles to emerge from the plates undeflected, the magnetic force on them must exactly cancel the electric force. This means that both of these forces should be equal and opposite. So, magnetic force is given by Q times V cross B, and the electric force is Q times E. So this is equal to Q times V times B sine phi. This is Q times E. And we just need to worry about the magnitudes now. So Q cancels out, and phi is 90 degree over here. So sine phi will just be equal to 1. This means that the magnetic field is electric field over the velocity of the alpha particle. So let's call this equation 1 that we will use later. Now we have to find the electric field. So electric field between the plates produced by the battery is equal to the voltage of the battery over the distance, which is given to be 8.2 millimeter. So we calculate that and we find this electric field to be 18,300 volt per meter. Now we have the electric field. The only thing we are left to find is the velocity of the alpha particle. Now we use energy conservation to find this. So as they enter the region between the plates, the energy there is Q times the potential difference, and this must be equal to half mv square, because the velocity or speed that the alpha particles gain is due to the potential difference between the plates. This is equal to, so let's solve this for the speed of the alpha particles now. So this should be equal to 2 times the charge times the potential difference. So let's call this V alpha so we don't get confused between small v and capital V. So this is V alpha and this is V alpha. This is V alpha. So this is the potential difference over the mass, and there is a root over. So we know the mass, we are given the potential difference and also Q, and we get this velocity to be 4.11 times 10 to the power 5 meter per second. Now we plug these two values into this equation 1 and we find the magnetic force to be 0.445 Tesla. The magnetic field is obviously, you can see here, as you can see, is perpendicular to the electric field here. Now, if the charges are moving to the right, the electric field points upward and the magnetic field is out of the page. So we say that using this equation. So if the charges are moving towards right, that means the forces is towards right. So the velocity is towards right, and electric field points upward, that means the force is upward. So the only way this is possible is when magnetic field is out of the